Assalamu alaikum wa rahmatullahi wa barakatuh. So today we're going to be going through a physics paper. We're going to do a little bit of a walkthrough. So we're going to have the question, and then after that we're going to give the answer right after that. Hopefully this comes and helps you with your GCSE physics revision, inshallah. So let's get right into it. So remember, don't write on this page. So the question says, a student investigated how the current in a filament lamp varied with the potential difference across the filament lamp. Figure 1 shows part of the circuit used, and that's figure 1. It says complete figure 1 by adding an ammeter and a voltmeter. Use the correct circuit symbols. So the correct circuit symbols are A for an ammeter and then V for a voltmeter. Now remember, a voltmeter goes into parallel. Because they're studying the filament lamp, we want to put the voltmeter right in parallel with the bulb. Then it says add a ammeter as well. Alright. So that we just add it anywhere. We could add it right here, we could add it up there, or we'll just add it over here. Perfect. So that would be 3 marks. So the next question says, figure 2 shows some of the results. The student reversed the connections to the power supply and obtained negative values for the current and potential difference. Draw a line on figure 2 to show the relationship between the negative values of the current and the potential difference. So, this is what the mark scheme says. It says, smoothed curved line of the correct shape. Don't accept a line that becomes horizontal. And it should pass through -4 and -2. -4 volts and -2 amps. So if we see that, -4 would be here, and then -2 would be over here. As we draw a kind of line that looks a bit like that with a pencil. And you would get 2 marks for that as well. Write down the equation which links current and potential difference and also resistance. So this is a formula question. It's one of the easy questions, 1 mark. And of course, if you've done revision, you should know that volts equals current multiplied by resistance. And that's enough. You don't have to write potential difference equals current times resistance. You could just draw the symbols. Alright, so the next question says, determine the resistance of the filament lamp when the potential difference across it is 1 volt. So if we look at figure 2, with the potential difference being 1 volt. So we look at 1 volts, we go up, and you can see this is 0.08 amps. So we know that current is equal to 0.08 amps, and then 1 volts would equal 0.08 the amps multiplied by the resistance, as we can see in this formula there. So if we rearrange that, we should get R equals 1.0 and 0.08. So the resistance would be 12.5 ohms. So that's just another formula question, but it's worth quite a lot of marks, so it's worth doing it, or worth giving it a try. Remember, you get marks for just putting the formula over there. Just putting that gives you a mark. So the next question says, a second student did the same investigation. The ammeter used a 0 error. The ammeter used had a 0 error. What is meant by a 0 error? So we should know that a zero error is just when the ammeter displays a reading when it's not connected to a circuit. So let's just quickly write that down. Ammeter displays a reading when not connected to a circuit. That's the end of question 1. Alright, so now this question says, figure 3 shows a LED torch. You can see a LED torch over there. The torch contains one LED, one switch, and 3 cells. Which diagram shows the correct circuit for the torch? Okay, so if we look at all of these, let's first find the differences. So we can already see that for this one, the cells are the opposite way, right? Now we know that if the current was to flow, then it would have to flow this way. It would not flow this way because the switch is over here. Alright, so that's just some basic logic. Alright, so this one would definitely not be the answer. Now, for this one, the cells are in these 2 cells over here. They're in different poles or different like charges. Right, there's a negative and a negative together. So that's also definitely not the answer. So the answer must be this one. Let's get to the next question. Write down the equation which links charge flow, current, and time. Alright, so again, we don't have to write the like current equals time. That we don't have to write all of that stuff. We just have to write the symbols. So Q will equal I and T. The torch worked for 14,400 seconds before the cells needed replacing. The current in the LED was 50 milliamps. Calculate the total charge flow through the cells. Alright, so one thing we know already is that the current was 50 milliamps. But we have to make sure that we convert this to an actual ampage. Alright, so that would be 0.05 amps. Then we know that the charge flow will be the amps times by the amount of seconds, which is the time. And if we do that, then you should get 720 coulombs. When replaced, the cells were put into the torch the wrong way around. Explain why the torch did not work. Alright, so this is 2 marks, which means that we'll need 2 reasons. Alright, or we need 1 reason and then an explanation. Alright, so if we do that, we could say there is no current in a diode in the reverse direction, because a diode only makes it go into one direction, and that's the point of a diode. And we can say that this is because a diode has a very high resistance in the reverse direction or the opposite direction. Hope that makes sense. Simple and easy. So now it says, write down the equation which links efficiency, total power input, and useful power input. So this is quite simple key stage 3 knowledge. Alright, so the next question is, the total power input to the LED was 0.24 watts. The efficiency of the LED was 0.75. So calculate the useful power output of the LED. So we know that the efficiency is 0.75, and that's equal to whatever the output was and how much we already put inside. So all we have to do is if we rearrange it, you'll have to times both of these together, and that will just be 0.18 watts. Alright, so now on to the next question. Just a second. Alright, so this says electricity is generated when water from the reservoir flows through the turbines. Write down the equation which links density, mass, and volume. Again, this is key stage 3 stuff, which should be knowing these formulas. We can just write P, which is the density, is equal to M, which is the mass, and then V, which is the volume. The next question says the reservoir stores 6,500,000 meter cubed of water. The density of the water is 998 kilograms per meter cubed. Calculate the mass of the water in the reservoir. Give your answer in standard form. So if we just put this into an equation, we would get 900 and whatever that is equal to M, and then that big number over there. That would mean that we will have to times both of these to get M. So if we did that, M would equal 6,487,000,000 and just a lot of zeros. And then the question says give your answer in standard form. This in standard form would just be 6.4787 to 10 to the power of 9. And then obviously it's kg, but the question gives us that already. And I want you lot to realize that the question is trying to help you here. It tells you to give it in standard form. You'd be surprised at how many students would forget about that and would just be too focused about actually giving this long answer over here. Alright, so we're on the next question now. Write down the equation which links energy transferred, power, and time. So this would be energy, or energy transferred, is equal to power and then times time. The electrical generators can provide 1.5 times 10 to the power of 9 watts of power for a maximum of 5 hours. Calculate the maximum energy that can be transferred by the electrical generators. So we know first that the time would be 5 hours times 60 minutes times 60 seconds, which is just 18,000, because we need seconds in order to actually put these numbers in the time in the formula. Then we know that the energy now would be 1.5 to the 10 times the 10 to the power of 9, and we do that times this time. Then you just get the answer if you put in the calculator, 2.7 times this, and then joules. So that's the answer. Figure 5 shows how the UK demand for electricity increases and decreases during one day. The hydroelectric power station in figure 4 can provide the same number that we had in the previous question, which is 1.5 times 10 to the power of 9 watts of power for a maximum of 5 hours. Give 2 reasons why this hydroelectric power station is not able to meet the increase in demand shown between 4 o'clock, which is here, and 16, which is also just 4 o'clock, which is right over here in figure 5. Well, we can see that it's much higher, right? And we could also say that the demand remains high for longer than 5 hours, because we can see that this goes from like the start of the day to the end of the next day, or the end of that same day. So we could say the variation in demand is much greater than 1.5 times 10 to the power of 9 watts. And we could also say the demand remains higher for longer than 5 hours. We can see that the demand is way too high, so this power station will not be able to meet the needs that go way more than 1.5. So the next question. So now starting question 4. So the question says, Figure 6 shows how much electricity was generated using coal-fired and gas-fired power stations in January for 5 years in the UK. Determine the percentage increase in electricity generated using gas-fired power stations from 2014 to 2018. We can determine the percentage increase by first seeing where the gas-powered ones are. They're over here, gas-powered. So the smallest is over here, the biggest is over here. So we have 10,000, take away that, and because we're doing percentage increase, we want to see how much it increased from the start, so we need the starting number, and then we need times 100, because it's percent, and then we get a percentage increase of 212.5. So let's just write that down. So now the question comes, give 2 environmental advantages of using a gas-fired power station to generate electricity compared with using a coal-fired power station. So we have to look environmental advantages of using a gas-fired power station, and we have to compare it with a coal-fired station. So one is that no sulfur dioxide is released, and we could also say that there's no solid waste that's left over. You could also say a lot of other things like coal power stations causes acid rain, and also gas fired power stations don't release particulates when they're used. This question, long question, The mean surface temperature of the sea ranges throughout the year. A change in the mean surface temperature from year to year indicates climate change. Figure 7 shows how the mean surface temperature changed from 1988 and 2016. A student does not believe that climate change is occurring. Explain how the data in figure 7 suggests that the student is wrong. You could say the mean sea surface temperature shows a steady increase over these 28 years, and we could see on the graph from this many degrees to this many degrees. You can see that we've used data and we've also made a point. That gives us 2 marks. A thermistor can be used to measure temperature. Figure 8 shows the resistance of 4 different thermistors. A, B, C, and D varies with temperature. Which of these 4 thermistors would be the most suitable to measure the surface temperature of the sea? Tick one box and explain your answer. Alright, we can first see that D goes way too far off the graph, and the sea definitely does not exceed 200 degrees Celsius. So we know we can just cross that out. Then we can see A, which is also off the charts. So sea temperatures don't go that far. We can cross that out as well. And then B, same thing. We can see that it goes way off the chart, right? And the resistance is very, very high when we're in temperatures that we're never going to get. So we can also cross that out. But with C, we're getting relatively good temperatures. So let's say it's in between the 25 and let's say it's in between here. We can see there's more of a change and is more realistic. So we would say C, because the change in resistance is the greatest between 0 and 25 degrees Celsius.